I really appreciate Mario's diplomacy in answering the questions. I hope to be as good as him because I'm not very used to do that, being an academic. So I am Mauro Olivieri. I am a consultant at the Barcelona Supercomputing Center in the European project. European Processor Initiative. Particularly on the RTL and circuit implementation of the RISC-V accelerator, RISC-V vector processor. What I would like to highlight is that anyway, what I'm going to say here is not my personal technical views, but it does reflect the views of the Barcelona Supercomputing Center after discussions with the colleagues, especially Matteo Valero and Jesus Labarta, that many of you know. So I don't know how many of you, probably many of you already know about the BSC. So because Barcelona Supercomputing Center hosted the RISC-V workshop 1 year ago in Barcelona, and it was the first European RISC-V workshop. So I will go quickly with some facts and figures about BSC. That doesn't work. This thing doesn't work. Okay. Sorry. Doesn't work as well. There is something here about the network. Okay, sorry. So Barcelona Supercomputing Center is a public entity. It is a consortium between 3 Spanish institutions, Spanish government, Catalan government, and 1 university. The purpose of that are providing supercomputing services all over Europe, doing internally a lot of research based on supercomputing facilities, and also education mission, because there are many PhD students at the BSc. The numbers of the BSc are continuously growing. This started with 65 people, and we are now in this moment more than 650. And this is due to the tremendous spirit of initiative of Matteo Valero, probably. The collaborations of BSc with main information technology actors are well known. All those companies directly contributed to the supercomputing capability of the center. This is Mare Nostrum 4. There is a reason I'm telling all this story to you, because it is, you will see in a few seconds, it is related to the open hardware, actually, and the perspective that Mario was introducing. Mare Nostrum 4 is the present installed supercomputer at BSc. You see it is a petaflop machine, and in the first implementation, it was number 4 in the world. The good news, the very important news, is that 1 week ago, even less than 1 week ago, there was a press release from the European Commission, and this press release says that the European Union has approved the funding for building 8 new supercomputers. The total budget for this investment is 840 million euros. And it will be devoted to developing 3 so-called pilot pre-exascale systems. So not yet exascale, but going to be, let's say, upgraded to exascale. We are talking about first deployment in 2021 and upgrading to exascale 2023, 2024. The interesting news is that one of them will be one of the first 3, the pre-exascale system will be Mare Nostrum 5. Mare Nostrum 5 is, of course, based in Barcelona. And the total budget is 220 million euros. Half of that will be paid by the European Union, half should come from internal co-funding. The interesting thing here is the last sentence that you see there, including new technologies. Before we go on, you probably noticed, for those who don't know, the strange, let's say, environment there. It is exactly like that. The supercomputer is hosted in what used to be a church. So this is a funny story. I will come back to that with the very last slide of this presentation. So I was saying the interesting thing is this, including new technologies, because here behind those three words, you have open hardware solutions and in particular RISC-V solutions. In fact, this was also written even in the call for proposal from the European Commission that new processor technologies should be addressed, and there is a specific part of the budget that is devoted to that. And when you say made in Europe microprocessor technology, you know there is presently no European microprocessor provider, microprocessor vendor. And the choice, as Mario already introduced, easily falls to developing something that is based on RISC-V. So, okay, this is something that is substantially overlapped with the introduction that Mario was doing. So I will go through quickly, but I will give some more numbers probably. We all know that HPC is important. I remember in the first day of the RISC-V workshop 2 days ago, there was a question from the audience. So why is RISC-V still totally absent, apparently absent from the HPC scenario? And this is a good question because HPC is a strategic market, strategic from many point of view, even political point of view. In fact, okay, again, sorry. Thank you. And so it is no surprise that if you look at what's happening in the world, you see a lot of investments from many actors, mainly the US, China, Japan, and what comes out from this picture is that obvious result that Europe is very late in this. But what is also the good news is that Europe is investing a lot, and it is at least trying to go faster as possible, to be aligned with the other main actors in the world. So what do we need for arriving at that level? Essentially, from the software, let's say at the software level and system integration, we are very good in Europe. There are industry doing that, the research institutions. BSc has a strong expertise in developing HPC software, runtime system, and so on. What we don't have is general purpose processors and accelerators. That one we really lack. And okay, one possibility is to say, okay, why do we really need that? Because overall, we have just seen the supercomputer in the church. It is not based on any European processor technology. It is based on Intel, AMD, and partially ARM technologies. But okay, this is probably a very similar slide that you showed, Mario. Anyway, but there are many reasons for developing European microprocessors. I will not go through that because it has been already described. So it is obvious in one sense that Europe should try to have it. It is obvious that ARM is not European anymore for two reasons: because of the SoftBank investment and the Brexit. So the present, let's say, public perspective, I am talking like with the point of view of a public institution like BSc is that Euro HPC initiative, the joint undertaking, is going to fund all the ongoing projects in high performance computing. And particular thing about Euro HPC, as I said before, is that it is expected that not all the money comes from the European Union. You have to provide usually 50% of the funding from internal sources, including the government, local government sources. This is the roadmap of the HPC. You see on the top part, we have the European Processor Initiative, let's say, roadmap. It is divided into 3 parts. SGA1, it is already ongoing. This is what Mario was presenting. There will be a second phase, and it is expected to have also a third phase. You see that there is ARM plus RISC-V. There was a question about that before. I will come back again on this concept in a few seconds. But EPI is not the only thing. So we have EPI and beyond. There are a lot of, let's say, initiative, and okay, I did not put the expected budget in the other initiatives, but I mentioned before there is a really huge investment. In particular, the one that I was mentioning is this pre-EXA procurement and pre-EXA deployment is the funding that I was mentioning at the beginning, the one that was announced 1 week ago. So this is the EPI roadmap, technically. This was partially highlighted by Mario very well. So we expect to have a first generation of the so-called general purpose processor in 2021, let's say end of 2020, start of 2021. And the second generation is expected to be by the end of 2022. In fact, you see on the top, there is this HPC chip and system, but there is also a kind, let's say, a bottom chip, accelerator chip and system. In fact, we are going to develop a test chip that is intended to demonstrate RISC-V RISC-V capabilities. It will be totally RISC-V based. So, what is the BSc vision in EPI? Basically, coming from a supercomputing center perspective, one of the main worries that the experts of BSc are talking about is that programmers should be able to survive the exascale transition. So, in one sense, the future as we imagine it now, somehow, let's say in a simplistic way, is that we have a lot of acceleration, a lot of GPUs like accelerators, and we are going to use programming paradigm like CUDAs and so on for exploiting those sources of parallelism. Okay, this is believed by BSc to be not a good perspective. It is necessary that we move this future vision to something that is more, let's say, feasible from the usability point of view, from the programmers, high performance programmers point of view. And it is necessary that architecture design, application software design, and runtime software design go together for obtaining the desired result. What has RISC-V to do with that? We are going to see in 1 second. So just a few details more about this vision. So this is the present, let's say, possible view of the future. Not the only one, but this may be one of the possible. We have to convince the European Union politicians to fund this initiative, and European Union politicians are going to follow what the industry is going to say. And okay, not only the industries, because BSc is also talking a lot with Brussels. But the risk is that we are going to invest a lot in something that may be not, let's say, actually usable in an efficient way, and especially in a practical scenario. BSc has a lot of experience in what it means to use a supercomputer for real applications, for real workloads. And with the requirements coming for variations in the workloads and other problems. So there is a possibility that at a certain point we are forced to change the direction of the future vision and look to something that is more well organized. What BSc is stressing is the need for hierarchical parallelism, heterogeneity, malleability meaning the capability of reacting to changes in the workload. For example, I need to run something very urgently, but I have an application already running on the system. The system should be able to adapt it. Long vectors, okay, vector processors are heavily involved in this vision, and we believe that long vectors are the solution for most HPC applications. And abstraction. Abstraction means that the programmers should not be worried about the hardware, and this is the role of the runtime system that I was mentioning before. So the point is, how can we get there at the right time? And how does RISC-V and open hardware comes into the play here? It does. Because, okay, this is a summary of what I was mentioning 1 second before. So why do we, let's say, look at RISC-V with particular interest? Sorry, I will come back to that in 1 second. Okay. Okay. We are not looking at RISC-V as a, let's say, magic solution. In fact, this relates to the question that was asked before. So is ARM present? Yes, it is. In fact, ARM is, let's say, a very good perspective for supercomputing. BSc has invested in ARM a lot. BSc still have a cooperation with ARM, an agreement with ARM, and this does not conflict with the development of RISC-V. What is RISC-V useful for in this moment is for building the accelerator part. It is, let's say, in one sense, you may say it is the easier. Yes, it is the easier. General purpose processor based on RISC-V with the superscalar power that is needed for HPC application is not available at the moment. In fact, so this is about the role of ARM. Something happened many years ago when the commercial processors killed the vector supercomputers because of the high production volumes that they allowed. And something is happening also now with the mobile processor that, for the power efficiency point of view, are more interesting are very interesting for HPC, for supercomputing applications. So it is not the case that we can say, okay, mobile processor, ARM processor are not interesting for supercomputing. In this moment they are, and in fact this is something that was done at BSc, all of them. So BSc has invested in ARM technologies in several projects, demonstrating that multi-core mobile processors can be the solution for, can be a winning solution for present supercomputing systems. But as I was anticipating, we have a different perspective, and RISC-V is interesting for that because of this. because RISC-V has no legacy constraints. We have the flexibility to move the future, as I was saying. RISC-V allows extensions, so you can use extensions to, let's say, in one sense, freely adapt your interface between hardware and software to the needs that I was mentioning before. In particular, what is very interesting is the vector extension of the RISC-V instruction set, because it is explicitly stated that it allows to be, let's say, it allows the programmer to ignore the microarchitecture. So the same vector extension can work in different microarchitectures. This is essential for the usability of the system, and in particular for the development of a really efficient runtime system in the supercomputer. And okay, it is also a very good point that RISC-V is contributed by committees which are world-class experts. And in one sense, you may say they are working for us. So they are doing a great job that a public institution, a public research center like BSC can exploit. Of course, there are limitations. One limitation that we are facing in this development, just the development of the RISC-V vector processor in BSC, is that many people's contributions in the RISC-V vector extensions equals to many different requirements and many features that not necessarily are needed to everyone, by everyone. I can tell you one example. For example, vector grouping, the LMUL, for those that are working on that, the LMUL parameter is something that is of, let's say, little interest for us, because we are developing a machine which has very long vectors. We are targeting at least 256 elements, each element being 64 bits, double precision floating point. And so having the possibility of grouping vectors is more a complication that, from the hardware point of view, than a real advantage. So this is just to tell you one example. Of course, the ecosystem. I was talking a few minutes ago with a friend of mine from ST Microelectronics. We were talking about the problem of ecosystem. This is something that is, of course, essential for the industry, and anyway, it is of less difficulty in the HPC world than for example, the consumer market, of course. For example, BSC is developing its own compiler tool chain for vector processing internally within the EPI project. This is something that is true. We are working on that, and of course, it must be considered among the limitations. And finally, the political issue. We are talking with Brussels. We need funding. We need money from Brussels politicians. What the politicians thinks, okay, the RISC-V Foundation is based in the US. What happens if the foundation decides that non-US companies can be members of the foundation? Okay, this is something that we are discussing with the foundation, actually, the generic problem. Okay, not this one that I was mentioning, it is some kind of crazy example, but there may be issues. And in fact, we are posing this kind of questions to not just from let's say, the perspective of a scientist, but from a perspective of a politician that must give the money to the scientists. We are approaching, I'm just coming to the end of the presentation. We are approaching the problem of developing this EPI huge work, taking as let's say, inspiration from this big church that you may know, the Sagrada Familia in Barcelona. That project is still ongoing. It is going to be finished in after 100 years. I will tell you very quickly. The point is that when it was initiated, the architect decided to do as the first thing the very tall towers, the one that you see, so that he was sure that even if the project was huge, nobody would have dared to stop the project. Okay, if you start from just the, let's say, the basic building, probably maybe that the politician again may decide to not doing anything more in the future. So we are starting to introduce very, let's say, innovative, very innovative view of the future in the supercomputing capabilities in order to have a possibility of guaranteeing really a future development. And then I come to the end of this presentation. Okay, this is a funny thing that Matteo Valero is telling in every of his presentation. Actually, you see here the book here. Maybe you know Dan Brown, novelist, wrote this novel that is actually talking about BSC, talking about Barcelona and BSC, and it is the dream of Matteo Valero to put the RISC-V based Mare Nostrum 5 in the Sagrada Familia. When you say, okay, Matteo, you are joking, he says, no, I am finding a deal with the Catholic Church. That's very funny. And so you see here Peter Shu, my friend Peter Shu is contributing to the project. That's me, and that's Dan Brown in person, and Matteo Valero, very nice person, of course. So I have to thank Matteo, Jesus, and Eugene, and Fabrizio for their contribution to these ideas that I showed you. And thank you for your attention.
One question, because we need to, let's take one question if you have, because we need to move to
the cricket team. Now, great talk.
Thank you.
And the title of your talk is Open Hardware and Open Software. And I appreciate this is WOSH, so you're going to talk more about hardware, that's fine. You mentioned something that personally interests me about your developing your own compiler.
Yeah.
And I know in the open source compiler community, one of the frustrations has been the lack of investment in the tools. If you look at GNU Fortran, which is widely used in supercomputers, it's entirely maintained by voluntary effort. There is no paid money. Whereas you look at C and C++, that's developed by paid professionals.
Yeah.
Can you tell me a bit more about the compiler development you're working and the plans to invest in the tools more generally?
Okay, it is not something that I'm working on. I know the people that is working on that. I can tell it is based on the LVM suite, and initially based on intrinsics. And it is going to support MPI and OpenMP. This is the programming paradigm that BSC is targeting, the mix of them. This is what I can tell you. Not because I don't want, like Mario was very, very well diplomatic in that, but I don't know really any more detail.
Okay, can I have one more question?
So coming back to the question about open sourcing your contributions that was asked before in the previous talk, I think Mario drew an analogy with the previous talk of Rick, saying that they would contribute something else but not the hardware design. And I was wondering if the context is not fundamentally different in the sense that your money is mostly public money, so which is different with respect to the Open Hardware Group in the US. So what's your policy regarding how you're going to spread the positive impact, the benefits on the European taxpayers at large? You know, how does the fact that the money that you use is mostly public have an influence on your policy for disseminating the results?
Okay, dissemination is a very important part in any European project. If you don't have a very clear plan of dissemination, you are not funded. So, okay. Basically, in this project, probably Mario can tell you something. Okay, in this project, what we are targeting is, okay, it is a very industrial, let's say. In this sense, it is a very special research project because it has a very industrial impact. And you see that the target is just the development of the chips, the processors. So this is something, so you are not only, let's say, addressing, let's say, research results, but just a commercial, a company is going to be funded inside the project. What about more about dissemination?
If I can add just a little bit, because
Okay.
I'm kind of responsible for
because yes, exactly. That's the point. They are responsible for communication of the project.
Yeah, come on.
We-
Okay, I'm here.
Okay, we have a very good website that is developed by Mario's various group. Okay. No, he's
I'm
not.
the one to shoot at, so I mean,
Okay.
please, we have to distinguish one thing. Okay, the first part, as I said, it's public money, right? But it was used to start as a seed to start something. So first, what Mauro just showed, it's just the first tiny little piece of the whole idea, because it's not going to finish. I mean, in 3 years, it's not going to finish. Even the second phase, it requires 50% co-financing by industry. And even during our first phase, a large portion beyond what has been given by European Commission needs to be invested in the project by the industry. So Europe is not paying for all. So industry needs to put some own money, and for that reason they have some own interest. Just to be direct, really, to your question, because it's a valid one.
I kind of want to add to the answer a little bit and modify your question just a tad. The Open Hardware Group is a legally registered nonprofit open source corporation in Canada, not in the US. It's okay. As well, we'll have a legal subsidiary here in Zurich and in Shanghai. And part of the industry matching components can come from this type of organization, because all of our funding will come from corporations, right? So that could be an interesting area of collaboration. Anyway, small adjustment.